Hi, everyone, and welcome to this presentation. Today, I'm going to give you a brief overview about the entire AV lifecycle and how data operations, or what we call ML DataOps, its technologies and the services fit into this product lifecycle. We are basing this information on about 8 or 9 years of experience in the AV space with customized solutions that we've provided for pretty much many, if I would say actually most of the large AV companies in the world, as we have taken them from inception and design and concept all the way to production and scale for multiple life cycles. But before we start, let me give you a quick overview of who iMerit is and who I am. So my name is Raj, and I am the Chief Product and Technology Officer at iMerit. But what does iMerit really do? So we are a custom ML DataOps solutions provider for enterprises. What does that really mean? As you all know, that ML Ops is the life cycle of an ML model and an ML application from concept to production. What we do is run a parallel pipeline called ML DataOps. So we don't really touch the model, but we touch, process, curate, and triage all the data that goes in and out of the model, whether you are collecting the data, whether you are training your model using ground truth data, testing, deploying, and collecting and triaging data from production. Our unique value proposition is what we call the SDS, or the Software Delivered Services business model. So you would see two kinds of service providers and technology providers in this ecosystem. On one spectrum, you have the service providers who are providing you human services, be it annotation, be it testing, be it production ops, etc. And the metrics here are skill and price. On the other hand, you will see technology providers who primarily follow a software as a service or SaaS model. And there, the metric is around features, performance, and price. What we provide is something unique and something in the middle. We provide an end-to-end custom solution to your custom problem. So our clients come to us and say, hey, we have a problem in our ML ops cycle, which is related to data. Can you solve it? And then we bring in the technology pieces and the services pieces, the expertise pieces, and bring them all together. Sometimes it often happens that we may not have one of these pieces, so we have to work with our large ecosystem of partners to get everything in place. And we solve that bespoke custom problem that you may have. That's why we call ourselves a custom ML DataOps solution. This is a unique business model, and we are seeing greater and greater adoption of this business model in our ecosystem, even from companies who are 2x, 3x, or even 10x larger than us. So we have an end-to-end technology suites for AV data ops, and we can take bits and pieces of that to suit your custom problem and the custom solution. We have experts in the loop providing high-quality data at scale, and given the employee retention that we've had over the last 10 years, our expertise was really, really high. Coupled to the retention, we have almost 9 years of experience in ML data ops, and we have worked with the majority of the tier 1 AV companies globally, both in the US as well as in Asia and Europe. So 200 plus global clients spanning not just in AV, but across 6 or 7 different verticals, including high-tech companies, healthcare, fintech, etc. We have over 3,000 experts who are skilled in annotation, test, and field ops services. And of course, from a diversity standpoint, we are a majority female workforce in our company. So we essentially process data across the entire life cycle of an ML ops system, whether it's traditional predictive AI that we have been using so far in AV, as well as in generative AI and large models that are gradually becoming the norm, even in the AV industry, and I'll touch upon that in the later slides. So starting from data collection, creating ground truth data with annotation, edge cases, simulation, test, model evaluation, trust and safety, STC, our simulation, test, and compliance, and field ops monitoring and triaging anomalies in the field. So we do the full circle for both generative AI and large models, as well as predictive AI and the current models that we use in AV. So here's a 20,000-foot view of the typical AV lifecycle. It is very idealistic, very top level, not meant to preach to the choir out here. You guys probably know this way better than I do, but I just wanted to put kind of the 7-ish stages that we go through in the AV lifecycle and the different pieces of requirements that come up in each stage. So while you are developing what we call AV ops, there is also the data processing that's happening in parallel. That's the data ops line that you see at the bottom. So for example, during the design cycle, it's about data collection, curation, making sure that the data is good to get into the development phase, while at the same time trying to generate the maps and updating them to make sure that the mapping parallel universe is also up and running. Development is all about data preparation, cleaning, normalization, creating ground truth, both with human in the loop as well as an automation, training data set creation and augmentation. And of course, more and more, and I'll talk about this later also, more and more we are seeing that we have to start working on certification scenarios and the whole concept of certification and compliance before deployment way back in the design and development stage. So that's something that we've started to incorporate as part of our development stage of the life cycle. And then, of course, as you get closer and closer to deployment, it's about testing your edge cases and the whole suite of test scenario creation, test data generation and augmentation, creating your simulation environments and actually running the simulation with hardware in the loop or with software in the loop, and then validating your model and your applications. And then once we go into production, it's about getting your compliance right before you launch, and then continuously looking at how your model and your application is performing when different variables in the environment and in the scenarios that you have tested changes in real life. And then, of course, the big part of what we do is collecting all the edge cases and anomalies that have in the field, triage them with technology and automation, as well as with human in the loops, and feed the results back into the development and the testing cycles. So sounds all good, and then therefore, and it sounds all serial, and therefore what we've seen in the industry is that at each stage, our clients tend to choose a different partner. So for example, data collection is a different vendor. Data curation and data management is often done in-house in a data management team as part of the extension of the data sciences team. And then, of course, data annotation is a different team. Certification is a third-party, usually consulting house or a test house that are brought in. And then for testing and simulation, you have a company who's probably creating the test scenarios and the environmental models, another company who's creating the simulation environments, and then you have the test house or the test team that is doing it. And then when you go into production ops, you have one team that's monitoring and doing teleoperations or teleassist in the field. There is a separate team, usually close to the data collection team, that is triaging the data in the field and putting it back into the test and dev cycles. So you could almost say that each stage has its own different partner or vendor that an AV company usually partners with. So what's the problem here? The problem is that these stages are not siloed and performs uniquely and all by its own self. There are constant feedback loops and dependencies that happen, and there are lots of moving parts altogether, especially as we kind of move from getting the technology right phase to getting the business and the economics right. So for example, if you are prepping and cleaning the data and starting to train your models, you would realize that there are major gaps in your models when you look at edge cases, etc., and you have to retune the models. You have to go back to the data collection and the data generation phase. And this constantly happens from any stage to any stage in a pseudo-random way. So therefore, are probably the biggest takeaway that we've learned in this experience is that it's very inefficient to have these siloed vendors and siloed kind of services and technology partners. An experienced one-shop stop for all your data ops needs, and having that one primary data ops partner is perhaps the most important decision that an AV company has to make pretty early in their process, especially when you are thinking of a concept, setup, and design stage. So let's break down those 7 stages into pieces and see what's going on in each one of them, what the trends are there. So first is data collection and data curation and prepping. One thing's for sure, we've gone past the stage that we are starting to train your network from scratch. It's not about retraining your network anymore, but it's about retraining. So that whole loop of having people to monitor all the data that's coming in, especially the anomalies and the edge cases, triaging that, having a human in the loop layer to bucketize them into the right categories, and then feeding them back into the development and test cycles. And then that data get processed into test scenarios, or the new ground truth is created from there, and the models are retrained and tuned based on that. So that is one important thing that we have to realize, that most of the data is coming from production, and it's not kind of pure virgin pre-training the models at this point of time. The other fun area that we kind of tend to look at is what we call the anomaly paradox. What does that really mean? It really, well, one of the big bottlenecks that we see there is that for many of our edge cases, you really can't test the edge case in the field because it is an edge case. It happens rarely, and it's usually from a safety standpoint, it is probably not acceptable. And if you don't have training data around that, you really can't train your models to kind of work around that edge case. Probably an extreme example, but let's say there is a person who's crossing a street, and a pedestrian crossing the street, and an incident happens. So let's say the person falls down, or she stalls and she's not able to move, or something like that. And your ego vehicle is approaching, and it needs to slow down. If it thinks that the person is not going to move, but it needs to also take care of the fact that if the person is able to efficiently cross the road, it might slow down, but it doesn't need to stop. So this is a scenario that you will never collect data from the field from, or hope you don't, because on first chance, there will be a mistake in estimating the velocity of the person, especially if they're falling or stopping in the middle. And therefore, the need, and that creates this gridlock that we almost often never kind of get out. And therefore, what we have realized is that synthetic data creation, or at least augmentation, right? You might have a use case, might have ground truth data on a person smoothly crossing the road, and then how do you augment that with these edge case scenarios of a person falling or something like that? For that, it's not a simple test case scenario generation or augmentation thing that anybody can do. It involves deep understanding of the vehicle dynamics, the vehicle model in general, the ODDs that you've developed around, and also an extensive knowledge in edge case scenarios. And this can only happen if the workforce that you are dealing with has been experienced over multiple generations of triaging and kind of been exposed to edge cases across different stages of maturity of your product lifecycle. That's a key thing that we have seen many of our clients stumble upon, and we've been able to successfully solve for them. The third aspect is we all deal with these data management and curation tools, right? And we've developed pretty elaborate search engines to be able to fish out the correct data, whether it's vector-based search, or NLP, or semantic search, etc. However, one of the things that we've often find missing is coupling this automation with the human experience and expertise in data mining, in data analytics, and in data filtering to really find the most relevant and the highest quality of data from the data set that you've collected, especially when you've been collecting data at scale or through production. or through production and not test vehicles. So the human in the loop factor, we feel is still important to get the highest quality data out of your data set. So here is an experience, here is a use case or a case study of a robotaxi company that we've worked with, and they were really struggling with the quality of the data. And this is where this piece about putting human in the loop and getting the highest quality data came in. And we did that. This company had its own kind of metrics around accuracy, at the same time improved efficiency because they were collecting data from production, and there was a huge amount of data that really couldn't be tackled with just plain human in the loop. So with the help of automation and, of course, expertise, we were not only able to get their quality issue solved and get to a 95% plus accuracy in the data, in the ground truth data, but we were able to do it at 2.5x the speed. So this was a win-win for both parties. And this is probably also an example of how that SDS, or the software delivered services business model that I talked about earlier, kind of fits in. Bespoke problem statement, and we provided a custom solution that addressed exactly the custom business metrics or the success factors of this client. And we were happy to kind of help them through that. Next comes data annotation. This is where it all started for us at iMerit. And this is kind of the core part for us to generate high quality ground truth data. But a few trends have been happening, especially related to AV and ADAS. Number one, we are moving from, separately from a unimodal system where we've been annotating LiDAR point clouds and then annotating RGB images from the cameras, etc., to more of a multimodal ground truth generation, where we are annotating simultaneously all the modalities or all the different sensors that are coming in, including point clouds from radars and LiDARs, RGB images, sonars, even the inertial sensor data that is coming in, fusing them all together to produce the perception map or the cost map, the output of your perception stack, is something that we've been doing. So essentially what we have done is, before you start to train your AI model, we have replaced that AI with HI, or human intelligence. And we are able to produce the ground truth that is exactly the output of your perception stack, which is a live perception map, frame by frame. And our whole goal is to generate that, and so you can take that data as is and be able to train your network without further processing. But that needs a level of expertise and understanding of how perception stacks and perception models work. And that is the expertise and the technique that we have been able to offer through our experience for over all these different years. The second trend that we are seeing is the need for automation. Yes, automation is there to address the economics of data at scale that's coming into AV and ADAS today, because many of these companies have gone into mass production. However, I don't think we are there where everything can be 100% automated. The human in the loop, especially for QC, a consensus on what the model is working on, especially when you're dealing with multimodal data, what the RGB result is on the image, for example, versus on the point cloud. Having that second pair of eyes is critical. Of course, automation still is the majority of the work getting done, and we've kind of reduced our time per annotation by an order of magnitude, but that human factor still needs to be involved. But that's not any and every human that can do the QC for you. This person needs to be experienced on exactly how these automation models work, what their biases are, what their inaccuracies are, and where they should pay special attention to which scenarios. And give the feedback not only to the client, but also to the ML designer who've been developing these automation models. And therefore, the model and the person, as I say, they have to be born and brought up together. And that synergy between technology and the workforce is really what differentiates us. And that's the third piece, where we can bring in our technique and our expertise, our technology and our talent, what we call the 3 Ts, and be able to create this high quality customized solutions for you. So here's another use case of bringing in our expertise and our automation and technology into pedestrian and traffic light detection. Same thing, custom problem of a client, and we were able to solve it by increasing the accuracy by 40% using our expertise and our technology, as well as a 50% increase in the economics of this project. Now let's talk about model training. So there's a paradigm shift happening there. And one of the things that we have noticed is that human in the loop is becoming more and more important as we can across this chasm. So we are moving into from the sequential PPA way of life, where we have the sequential models for perception, for planning and predictions, and then the action models, right? And then, of course, there are redundancies across different hardware platforms, etc. We are moving from this way of life to a fully integrated end-to-end large model with multiple different heads tackling different things. That's perception, planning, mapping, input and output triggers, etc. Now, what does that represent? The first kind of issue that we've seen is, of course, a transitioning one, which is around robustness and safety. Of course, everybody says that, yeah, in a few years, this will not be a problem, but until then, what do we do about it? And therefore, when you are training the models, setting the human in the loop information as kind of the training guardrails is absolutely critical. So in the car, when you are running it, the architecture of most of the folks that who have been working in this field of these large models for AV have shown that they need this robotics guardrails and robotics kind of deterministic validations. That's during inference inside the car. But during training, how do you set these guardrails? It has to be from human information and human scenarios and human expertise. The second piece is around behavioral models and explainable AI. When you are creating these behavioral models for your path planning and for your predictions, you have to bring in the human factor here to kind of create a scenario where your cars are behaving in a way that is socially acceptable and is consistent with other human drivers. There is a lot of human in the loop information that we are currently working with our clients to feed in to make these prediction models really, really robust. And then the third piece that's becoming more and more prominent is explainable AI. This is not just for security and liability reasons, such as insurance or law enforcement, etc., but also to provide a good user experience to the consumer in your Robotaxi or other autonomous vehicle. I mean, sometimes, even when I sit on a Robotaxi, I get very surprised as to why is this thing slowing down at an intersection? I don't see anybody around, because that's probably not what I would have done as a driver if I were in that situation. But having this kind of a human voice and a human language narrate essentially what the perception stack is thinking and therefore what the planning algorithm is doing is, I think, great for a human kind of user experience and to make you feel comfortable that's there. So with VLAMs and other action models that are going around, this is becoming a big area for investment, especially when human, and this especially needs human in the loop to do this translation. But again, the expertise matters. You have to understand the real-time perception map, and then in real time, frame by frame, you have to convert that into language that a common person can understand and feel comfortable about. So human in the loop in every aspect of these large model-based navigation stacks that are being developed. Here is, again, a use case of how we improved both the accuracy as well as the productivity of VLAN model for one of our clients for autonomous mobility. Mapping is also going through a paradigm shift. So we have been working, and we have a very large business with our clients around HD mapping, development, and update. And that's a serialized cycle that goes on, but it's very decoupled and almost isolated from the main perception and nav stack kind of development. That's changing. You've probably seen presentations from Nero, Wave, and others where, number one, we are tending to move away from these really heavy, really dense, high information kind of concentration HD maps into essentially non-terrestrial or simple Google Maps or ADAS-related standard definition maps, or even mapless, as some folks have, such as Wave and others, have been working on. From there, you create a geospatial model or a mapping model that's off-board, outside your nav stack. And then you feed the result of this model into your multi-headed perception model, which probably has a mapping head in it. And then what you generate is a semantic map with the localization information, which then gets fed into your behavioral models and your action models to complete your PPA cycle. Now, how does that change data operations? Well, you are not doing mapping data anymore in isolation. It has to be closely integrated with the development of the nav stack. And that is where we have been able to provide most of our values, because we've been working on with our clients on their nav stack data, and then coupling that and making mapping a seamless part of their navigation model experience and their development and deployment is paramount. So again, when you think about your data ops partner, this is one angle that you might have to think of in the future as you move towards these large models. Here is another use case of a self-driving car company where we've been able to kind of help them not only develop their HD maps and make their transition of those maps and integrate them with these large models with 95% accuracy and major improvement in their economics. The fourth area that we talk about is what we call trust and safety. You can also call it STC, simulation, testing, and compliance. But one thing, and we have extensive experience and we'll go over that in some use cases later on. But one of the big takeaways over here is that we should not be treating this whole pie as kind of separate, isolated. There is a test house who will do the testing. There is another vendor who's going to do the data generation for testing. There is another guy who's going to do simulation environments or environmental models. There is another guy who's going to create some of this data augmentation or test scenario generation, etc. We have to think about test and validation as an end-to-end integrated kind of solution. Otherwise, it becomes piecemeal. They don't speak to each other. It's not a flow that you can iterate on. It's not a flow that you can go back to and fall back, come back again when you see that you've hit a brick wall in some test scenarios, etc. So having a single end-to-end customized and a continuous development plus deployment kind of a framework with a trusted partner is probably paramount to get over your STC hurdles. And this kind of loop should include your test scenario generation, extraction, interpolation, augmentation, all that stuff, your model and application validation, simulation environments, and also these extrapolations of the ground truth and putting functional objects in your simulation and in your test environments, etc. We've had a lot of experience doing that, whether it's predictions for people who are using the road or the cars, what they would do next and how they would interact with each other, etc. Creating this test scenario, even creating test data and augmenting existing test data to kind of cater to these scenarios. So between an example on vehicle dynamics and behavior prediction, we have over 1,000 people who've been trained and experienced in this area. And we've gone through over 5 million, maybe close to 6 million now of these things, while maintaining the accuracy standards of 97, 98, 99%. That's required so that you can take this to compliance directly. The big thing with compliance is that today it's an afterthought, very frankly. We all get to compliance once the rubber tries to hit the road, essentially getting the cars into deployment. And then we realize, hey, there's a lot that needs to be done. There's a lot that needs to be tested, developed, etc. So let's go back. Bring in the right experts, bring in the right test scenarios, bring in the right data. That is expensive, untenable most of the time. And therefore, let's incorporate, think about compliance early in the stage. If you remember in the lifecycle slide, I had put kind of compliance-related test scenario generation early during the design and development phase. I think we should start thinking about them and considering them, even when you've started defining your ODDs. You should have a very good partner who understands these global compliances. And then again, today we tend to go, okay, to get to the global standards around ISO, etc. Let's find this one test house or this one partner. EU will find another partner, US, another partner. Oh, this new NCAP 2027-28 has come in. That mandate has come in. Let's find an NCAP specialist, etc. Usually that doesn't work. You will end up with kind of silos, compliances that don't work with each other, inefficiencies and redundancy creep in, and being able to follow up and keep updated over time is something that will kind of fall apart or become very, very inefficient. And therefore, you need to have this one partner who can create this fully integrated test and dev data ops cycle for you. They have the end-to-end ecosystem support that can cater to all your compliance need. Let's not get into fragmented certifications, and be able to constantly update and get your vehicles and your fleet updated on a yearly basis on global deployments. So again, people with experience across multiple life cycles in deploying the cars across all the regions that are relevant to you. The last kind of pillar in the life cycle is around production of maintenance and upgrades. As we all say that a success in the AV business is not the 99.999% of the time that everything works exactly as expected, but that 0.001% of the time that we meet an edge case and things don't go according to plan, right? And by according to plan, it kind of is our high human expectations for how impeccably a machine should work. So the need for production ops and maintenance is absolutely critical for the success. This is what defines the economics as well as the perception in the world and gets your technology right. So we break it down into 4 parts. One is, of course, drift ops, seeing how your model and your application is behaving when things around it change, when the environments change, when the assumptions that we had used during development changes, etc. Because that's really how the world works. It's constantly changing, especially if you're deploying across different cities or geographies, and then you should be able to RCA all that. Remote operations, being it performance tracking or different levels of teleassist and teleoperations. That's critical to make sure that you are able to support your fleet in the field. Anomaly triage is a big part of what we've been doing, which is basically collecting all the real-time edge cases and anomalies in the field, triaging that, a small percentage of that with human in the loop as needed, categorizing and bucketing them rightly so they can be fed back into the development cycle where you are recreating ground truth and tuning your networks, or into the test cycles to augment and create new test scenarios. And of course, remote diagnostics. That's really how to make sure that your fleet and individual cars are performing in the field and there are no safety or any execution issues. So yeah, that's the lay of the land. That's all the lessons learned that we've gotten over the 9-ish years that we've been in the business and gone through multiple product life cycles. So if I can summarize them, I think we will all agree that we are done with the hype curve and the hype cycle and everything. So we had all set off on this AV revolution phase. We've proved it. We've kind of gotten the technology to where it's supposed to be. Now it's about getting the economics and the business right. And that is an evolutionary phase where we need to put the right processes and the right partners and the right ecosystem in place. When it comes to ML data operations, I think the big need today is not to have a piecemeal solution to your data ops partner or vendor, but to have a single end-to-end data ops solution. And that can only be fulfilled with a single end-to-end data ops partner to close the full lifecycle loop. So first, some kind of acceptance criteria, end-to-end. It has to be a custom solution. We talked about our SDS model with human in the loop, the talent, the expertise and the experience that they bring in, and of course, the technology. And these have to be synergistically, like I say, bond and brought up together and interacting together. Let's not forget human in the loop. It's still relevant, it's still important, especially as we transition through scale, but maintain the high levels of quality and bring in new technologies into this ecosystem. We cannot get rid of humans. We should not be thinking about it that way. Instead, what we could do is bring in automation that makes humans more accurate and economically more feasible. But let's not completely phase HITL out of the loop. Failures are, in our experience, almost as important, if not more important, than success stories. We have gone through a lot of failures with our clients, frankly, in different stages of the development cycle. That has actually told us a lot about what not to do. And when you pick your data ops vendor or partner, I think this is an important kind of gauging factor to see how many product life cycles they have gone to, what are the lessons learned they have from their failures, and how they can preempt that in your development cycle so that you don't have to go through the full cycle and then fail at the very end, how that can be preempted. And it will definitely help shorten your learning curve towards profitability. Focus on bespoke. You have a differentiated custom solution. These custom solutions have differentiated and custom problems. You have your custom business and metrics and your success factors. Your partner should be able to take care of them in a very customized way. Please, this is something that I tell all the clients, even if you're not selecting us, be very mindful that you have very custom needs for you to differentiate and to get to profitability fastest. And therefore, pick up a partner who's able to be as customized as possible in catering to your problem statements. And this partner has to continuously adapt. There are lots of challenges, there are lots of trends, new technologies coming in, lots of ambiguity still in the system that needs to be flushed out. They can collect the information from the field, they can collect experiences from their other vendors and be able to support you kind of quickly navigate through these changes and adapt through all the new technologies that are coming into the system. Well, before I end, just wanted to give you guys a quick glimpse of a very large autonomous vehicle company that we have been ramping with. Before COVID, actually this graph is a bit outdated. We still need to put in the 2023 and 24 bars in here. That's gone up well above 2,000 people. But we started with labeling, 300-400 people. But after COVID, when we started deploying a fleet, all these other things kicked in around test, trust and safety, compliance, production ops, anomaly triage, etc. And therefore, we've been exponentially growing not on just our technology, but also our human services to over 2,000 people in the last 3 or 4 years. So that's what we offer, and that's what we propose. This is what our lessons learned are from 9 years of being in this industry and going through success and failures. Please feel free to reach out to me or anybody else at iMerit as we you go through your journey and we go through ours. We'll be happy to share, partner, and help you with anything that we can possibly help you with. So thank you very much and have a great day. Bye-bye.